Decentralized neural assembly beats centralized refineries. Efficiency: neural assembly versus heat cracking. Traditional biofuel: centralized refineries use 30–40% of input energy for heat pressure cracking. Energy loss in transport to from facility. EndoFuel: AI-optimized molecular assembly at source. 85% plus energy retention. Zero transport energy cost. Real-time neural pathways optimize bond formation. 2. Realism: decentralized production versus infrastructure lock-in. Traditional biofuel requires billion-dollar refineries, 10-plus-year ROI, and depends on feedstock transport. EndoFuel uses portable neural processing units deployed at forest sites. Modular, scalable, no pipeline needed. 3. Capacity: carbon loop reclamation versus petroleum replacement. Traditional biofuel, carbon neutral at best, competes with food crops. Limited feedstock, still combustion-based emissions. EndoFuel, carbon negative, captures methane, CO2 from decay, infinite renewable feedstock from forest floor waste, and sequesters carbon in production. Right now, beneath every forest on Earth, a slow-motion explosion is happening. Billions of tons of organic matter, leaves, branches, deadfall, are rotting. And as they rot, they release methane and CO2 into the atmosphere. Uncontrolled, unmonitored, unstoppable. We call this natural decay. What we should call it is wasted energy. Because hidden in that rot is enough diesel fuel to power civilization. We just needed to teach a neural network how to scavenge it. Let's talk numbers. The world's forests drop 50 billion tons of organic matter onto the forest floor every year. As it decays, 2.1 billion tons of methane released, 15 billion tons of CO2 released, zero energy captured. This isn't fossil fuel extraction. This is carbon that's already in the atmospheric cycle. We're just letting it leak out uncontrolled. Traditional biofuel tried to solve this with industrial refineries. Centralized facilities, heat cracking, chemical processing. They take biomass, truck it hundreds of miles, burn massive amounts of energy to refine it, then truck the fuel back out. The energy cost of making biofuel often exceeds the energy you get back. It's a net loss disguised as innovation. And then there's the diesel problem. Electric vehicles work great for commuters. Hydrogen might work for short-haul trucks. But heavy industry, deep-sea shipping, remote mining operations, these need energy density that batteries can't match. A gallon of diesel contains 37 megajoules of energy. A lithium battery of equal weight, 0.9 megajoules. It's not even close. So we have two choices. 1. Keep burning fossil diesel and destroy the climate. 2. Find a way to make diesel that cleans the climate. That's where EndoFuel comes in. Here's the breakthrough. Instead of trucking biomass to a refinery and blasting it with heat, we bring the refinery to the forest. And instead of burning energy to crack molecules, we teach an AI to assemble them. Neural diesel, what we call EndoFuel, is produced through decentralized, AI-optimized molecular assembly. Portable processing units stationed at the forest floor. Real-time machine learning optimizing bond formation. Zero transport cost. Zero centralized infrastructure. The neural network doesn't just mimic combustion, it replaces it. It scavenges the exact molecular pathways that nature uses during decay, but redirects them toward high-density fuel synthesis. This isn't biofuel, this is algorithmic carbon reclamation. Traditional refining is brute force. You heat crude oil to 400 degrees Celsius, crack long hydrocarbon chains into shorter ones, separate by boiling point. It's expensive, it's energy intensive, and it only works on petroleum. EndoFuel uses a different approach, molecular scavenging. We trained a neural network on the decomposition pathways of cellulose, lignin, and hemicellulose, the three main components of forest biomass. The AI learned to identify which molecular bonds are worth breaking, which intermediates are stable enough to isolate, and which assembly pathways lead to high energy density fuels. Think of it like this. Nature is already breaking down the forest floor. The AI just redirects that breakdown toward diesel instead of methane. The magic happens in a unit the size of a shipping container. Inside, biomass intake chamber, shreds and sorts forest floor material. Neural processing core runs the molecular assembly algorithms. Enzymatic catalyst beds accelerates bond formation without heat. Output separator isolates diesel-grade fuel from byproducts. It runs on solar panels and its own fuel output. It's completely self-contained. You drop it in a forest, connect it to a biomass collection system, and it starts producing. No pipelines, no transport trucks, no billion-dollar infrastructure, just the forest, the machine, and the algorithm. Estimated cost per unit, $2 to $5 million. Compare that to a traditional refinery, $10 to $20 billion. You could deploy 4,000 EndoFuel units for the cost of one traditional refinery. Here's where it gets wild. The AI doesn't just run a fixed recipe, it learns. Every batch of forest floor biomass is different. Oak leaves versus pine needles, fresh deadfall versus year-old rot, fungal colonization levels, moisture content, all variables. A traditional refinery would struggle with this variability. It's optimized for consistent petroleum feedstock, but the neural network thrives on it. It analyzes the input biomass in real time. Spectroscopic analysis identifies molecular composition. The AI selects optimal enzymatic pathways. Catalysts are dynamically adjusted. Output quality is monitored and fed back into the algorithm. Over time, the system gets better. It learns which forest types produce the best fuel, which seasonal conditions optimize yield, which microbial populations enhance breakdown. It's not a factory. It's an evolving ecosystem of algorithmic scavenging. Now let's talk about why this is carbon negative, not just carbon neutral. Scenario 1. Natural decay. What happens now? Forest floor biomass rots. Releases 100 units of carbon as CO2 and methane. Methane has 28 times the warming potential of CO2. Net atmospheric impact. Pose 130 carbon equivalent units. Scenario 2. Traditional biofuel. Biomass truck to refinery. Emissions plus 110 units. Refinery processing. Emissions plus 130 units. Fuel transport. Emissions plus 5 units. Combustion releases. Each 100 units. Net. Each 145 units. Worse than doing nothing. Scenario 3. EndoFuel. On-site processing. Emissions plus 2 units from solar self-fueled operation. Combustion releases. Least 100 units. But prevented natural decay emissions. 130 units. Net. East 1.2. 130. East 28 units. That's a 28 unit carbon removal per ton of biomass processed. Scale that across global forests, and you're looking at multi-gigaton carbon sequestration. Where does EndoFuel make the most sense? Anywhere with 1. High biomass accumulation, temperate and boreal forests. 2. Remote location, where diesel is expensive to transport. 3. Heavy machinery use, logging, mining, agriculture. Target 1. Pacific Northwest logging operations, 500,000 tons of logging/generated annually. Current practice, burn it or leave it to rot. EndoFuel potential, 150 million gallons of diesel equivalent, enough to power the entire logging fleet, plus export surplus. Target 2. Amazon basin remote communities, diesel costs $8.12 gallon due to transport, forest floor biomass unlimited. EndoFuel production cost, $1.50 gallon, enables energy independence, plus carbon sequestration. Target 3. Siberian mining operations, currently burn fossil diesel at extreme cost, surrounded by boreal forest with massive biomass accumulation. EndoFuel provides local production, plus eliminates transport risk. The economics are staggering. Phase 1. Pilot deployment, years 1 to 3. 100 units deployed globally, 300 million capital investment, creates 2,000 direct jobs, manufacturing, deployment, maintenance, produces 300 million gallons diesel equivalent annually, revenue at 3 gallon 900 millers year, carbon credits at $50 ton, 420 millers year, total annual revenue, $132 billion, or OI, 4.4 times in year 3. Phase 2. Regional scaling, years 4 to 7. 2,000 units deployed. Production, 6 billion gallons year. Revenue, 26 billion year. Replaces 8% of global diesel consumption. Carbon sequestration, 560 million tons. CO2 year. Phase 3. Global transformation, years 8 to 15. 20,000 units deployed. Production, 60 billion gallons year. Revenue, 260 billion year. Replaces 80% of fossil diesel in heavy industry. Carbon sequestration, 5.6 billion tons CO2 year, equivalent to removing 1.2 billion cars from roads. This isn't a moonshot. This is a market-driven carbon removal engine. Here's why EndoFuel wins on pure pragmatism. It works with existing infrastructure. Every diesel engine on Earth can run on EndoFuel. No modifications needed. It's chemically identical to petroleum diesel, just cleaner burning and carbon negative. That means no engine redesigns, no fueling station overhauls, no consumer behavior change, no trillion-dollar infrastructure replacement. Compare that to electric vehicles. Requires global charging network rebuild, $5+ trillion. Hydrogen. Requires entirely new production, storage, transport systems, $8+ trillion. Traditional biofuel requires massive refinery construction, $2+ trillion. EndoFuel requires portable units, plus existing diesel infrastructure. Capital cost, $200 now or $400 billion globally. It's not just better technology, it's the only technology that can scale fast enough to matter. But the real revolution isn't technological, it's economic. For centuries, forests were valued for timber. Cut the trees, sell the wood. A one-time extraction that leaves degraded land. EndoFuel flips the model. The forest floor becomes a perpetual energy farm. The value isn't in cutting trees, it's in keeping them alive to generate biomass. Economic transformation. Forest communities become energy exporters. Indigenous land rights gain massive economic value. Conservation becomes profitable, not charitable. Rural jobs in energy production, not just extraction. Example, a 10,000-acre temperate forest. Traditional timber value, $2.5 million one-time harvest. EndoFuel value, $8 to $12 million annually, sustainable forever. Suddenly, it's worth more to preserve the forest than to clear-cut it. This creates a virtuous cycle. More forest preservation, more biomass, more EndoFuel, more carbon sequestration, more climate stability, more forest growth. We're not just solving diesel, we're solving deforestation, we're solving rural poverty, we're solving the carbon crisis, all with one technology. Where are we now? Phase 1, proof of concept, completed. Neural network trained on cellulose decomposition. Lab-scale molecular assembly demonstrated. Diesel equivalent fuel synthesized at 92% purity. Phase 2, pilot unit, current, 18 to 24 months. First field deployable unit construction. Target Pacific Northwest Forest Site. Goal, 10,000 gallons short month production. Real-world optimization learning. Phase 3, commercial deployment, 24-36 plus months. First 10 commercial units manufactured. Regional partnerships established. Logging companies, conservation groups. Regulatory approvals secured. Carbon credit verification. Phase 4, scaling, 36 plus months. Manufacturing partnership for 100 plus units year. Global deployment across target regions. Open source algorithm sharing for academic research. Policy advocacy for carbon credit standardization. We're not waiting for government mandates. We're building this now. The technology works, but policy can accelerate it. Key policy enablers. 1. Carbon credit standardization. Current, fragmented, inconsistent verification. Needed, standardized protocol for avoided decay emissions. Impact, 50-100-ton carbon removal value. Massive revenue stream. 2. Rural energy incentives. Current, Subsidies favor centralized energy. Needed. Credits for decentralized production in forest communities. Impact. Faster deployment. Economic revitalization. 3. Diesel replacement mandates. Current. Heavy industry has no clean fuel requirement. Needed. Carbon-negative diesel mandate for mining, shipping, agriculture by 2035. Impact. Guaranteed market demand. 4. Forest preservation credits. Current. Conservation land often economically unproductive. Needed. Payment for maintaining biomass-generating forests. Impact. Aligns economic incentives with environmental goals. These policies don't require new technology. They require political will. The biggest barrier isn't technical, it's psychological. For decades we've been told, combustion, bad, diesel, fossil fuel villain, only electric and hydrogen can save us. But that narrative ignores reality. Heavy industry needs energy density. Remote communities need local fuel. We can't electrify a cargo ship or a mining excavator. Not with current battery technology, maybe not ever. EndoFuel doesn't ask you to give up combustion. It asks you to reimagine it. What if diesel could clean the air? What if heavy machinery could sequester carbon? What if the forest floor became the world's distributed refinery? This is the narrative shift. From stop using fossil fuels to start using algorithmic fuels. From prohibition to transformation. From sacrifice to innovation. From fighting nature to working with it. That's the story we need to tell. The forest floor is rotting right now. Methane is leaking. Carbon is escaping. Energy is wasting. But it doesn't have to. We can teach an algorithm to scavenge that decay. We can build portable refineries that sit at the source. We can produce carbon-negative diesel that powers civilization while cleaning the planet. This isn't science fiction. The neural network is trained. The chemistry is proven. The economics are viable. All we need is the will to deploy it. The combustion engine isn't dying, it's being reborn. Welcome to the AI diesel revolution. Welcome to EndoFuel. Welcome to the future we're building, one forest at a time.